Hello there. Welcome to AP Calculus Lecture 2.3a, where we go over the product and quotient rules. So this is a way to take derivatives, shortcuts, so that we don't have to use the definition of the derivative. So we're going to use the power rule a lot within the product and quotient rules. But these rules are great because they save us a ton of time. So first of all, the product rule, I'm going to give you the book formula for that. And d over dx just means take the derivative with respect to x. So let's say we have two functions, f of x, and product means multiplication, right? So times g of x. So the derivative of that would be the f of x, the first function, times the derivative of the second function. So times g prime of x plus the second function, g of x, times the derivative of the first function, f prime of x. All right, crazy how that works out. Let's put it in writing because that's really kind of probably easier to memorize. So it's the first times the derivative of the second plus the second times the derivative of the first. So memorize that and you should be good. And we're going to do a lot of practice problems. So I think you'll find this technique to be pretty easy. Our first example is find the derivative. So let's write that as find f prime of x if f of x is equal to 3x squared plus 1 times the square root of x. Now I'm going to rewrite the square root of x just to make this a little easier. F of x is equal to 3x squared plus 1 times x to the 1/2. All right, now let's go through the product rule. The first, 3x squared plus 1 times the derivative of the second, that's 1/2, times x to the minus 1/2. So first times the derivative of the second plus the second x to the 1/2 times the derivative of the first. Well, what's the derivative of the first? It would be 6x. So times 6x. Now we want to clean this up. So this x, we've got to make the exponent positive, so that's going to be 3x squared plus 1 over 2x to the 1/2 plus 6x times x to the 1/2. All right. I am fine with this as your answer. Now the book will probably make this into a radical. The book would probably do it this way. 3x squared plus 1 over 2 times the square root of x plus 6x times the square root of x. Now x times the square root of x is x to the 3/2. They might do that. I am fine with you leaving it this way. It is a little cleaner to at least bring the radicals back in for that. So there you go. All right, so let's do another example. We get increasingly fancy with each one. So let's find the tangent line equation to f of x equals 3x minus x squared times 2x minus x squared at the point 1, 2. Okay, so if we didn't know the product rule, we would have to FOIL all this out and take the derivative with the power rule. But we know the product rule. So f prime of x, we've got to get the derivative so we can get the slope. The first, 3x minus x squared, times the derivative of the second. What's the derivative of that? It's going to be 2 minus 2x. Plus the second, 2x minus x squared, times the derivative of the first. What's the derivative of the first? It's 3 minus 2x. Now to get the slope, we have to find f prime. We're going to plug in the x value. So we're going to plug in 1 into the derivative. So that's going to be 3 times 1 is 3, minus 1 squared, would just be 1, times 2 minus 2, so that's 0, which is great. All right, and then this part would be 2 times 1, which is 2, minus 1, times 3 minus 2. So that's going to be 0 plus 1 times 1. So the slope is 1. The slope is 1. So we have the form y minus y1 is equal to the slope m times x minus x1. So y1 is 2, y minus 2 is equal to 1 times x minus 1. I'm totally fine if you leave it that way for my sake. The book will probably do slope-intercept form, so that would be, just doing that real quick, y minus 2 is equal to x minus 1. So y is equal to x, and add 2 to both sides, plus 1. So that's probably what the book would do, but you don't have to do that for me. All right, great. Okay, let's see, erase the whole thing here. Do a couple more examples of the product rule and then move on to the quotient rule. All right, so we want to find the derivative of h of x is equal to 2x to the fourth plus 3x plus 7 times x to the fifth minus 3x squared. So this is really, a good practice using the power rule and the product rule. So h prime of x. So you would have to multiply. If you didn't know the product rule, you'd have to multiply all that out. So you'd have 6 terms, and what if you made a mistake in the multiplication? Then you're going to get the derivative wrong. With the product rule, we'll just do the first, 2x to the fourth plus 3x plus 7 times the derivative of the second, that's 5x to the fourth. Don't forget the exponent. I have students accidentally, they know it, but what they do wrong is they'll say the derivative of this is 5x and forget the exponent. That's happened so many times. So minus 6x. So there's the first half. First times the derivative of the second plus the second, x to the fifth minus 3x squared, times the derivative of the first. Well, that would be 8x cubed plus 3. All right, and that's all that you need to do. Now the back of the book might then take that, they'll give you that answer and then multiply all that out. But there's no reason to do that. Usually we're finding the derivative at a point. So we would just plug in whatever the x value is and find the value of the derivative. So there's no reason to simplify it. Let's just leave it like that. Okay, last product rule example. Let's say f of x is equal to 2x to the fourth minus 7x minus 3 times root x minus 1 over x plus 1. And we want to find f prime of x. Okay, let's rewrite the second term. So we've got 2x to the fourth minus 7x minus 3. It's easier if we call that x to the 1/2. And 1 over x is the same as x to the minus 1. So now it's much easier to take the derivative of this second term. So f prime of x is equal to, first, 2x to the fourth minus 7x minus 3 times the derivative of the second, 1/2 x to the minus 1/2. And then the derivative of x to the minus 1 would be negative 1 times this negative out front would be plus x to the minus 2. Negative times negative makes a positive. And then the 1 goes away. First times the derivative of the second plus the second x to the 1/2 minus x to the minus 1 plus 1 times the derivative of the first. We're going to run out of room here, but that's going to be 8x cubed. I think I'm going to make it 8x cubed minus 7. So that's the derivative, but I'm going to go ahead and follow the rule of cleaning up, these negative exponents. So the answer I would like you to report is 2x to the fourth minus 7x minus 3 times 1 over this x to the negative 1/2, bring it downstairs. Let's go ahead and put the radical back in. 1 over 2 root x plus 1 over x squared all right, and then plus, I need to check something real quick, plus root x minus 1 over x plus 1 times 8x cubed minus 7. All right, my paper has a negative there, so I want to make sure that we did this right. Okay, the first times the derivative of the second. So this derivative is going to be 1/2 x to the minus 1/2, and then minus 1 over x, so that'd be negative 1 times the negative would be plus x to the minus 2. So I believe the positive is right here. So the paper that I have is wrong, although I never looked at it when I taught the class, so I probably did it right in class. Okay, so that is the product rule. Let's move on to the quotient rule. It's a little fancier. So quotient, we have division. So we're going to be dealing with a fraction. We can just call it division. So for the quotient rule, let's say given q of x is equal to f of x over g of x, what is q prime of x? Okay, so here's the formula. Q prime of x is equal to the bottom, g of x, times the derivative of the top, f prime of x, minus the top, f of x, times the derivative of the bottom, g prime of x, all over the bottom, g of x, all squared. Okay, so that looks fancy, but it's actually not too bad. In words, this is what I would suggest that you memorize. It's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So after you do a few of these, you'll have it all memorized. Okay, so I tell you what, I am going to try to squeeze our first example. I've just got 2 examples of this. So let's say that f of x is equal to 6x cubed plus 2x squared minus 14x over 3x squared minus 6. We want to find f prime of x. Okay, let's go through the chant. The bottom. So f prime of x is equal to the bottom 3x squared minus 6 times the derivative of the top 18x squared plus 4x minus 14. Okay, so we're a third done. We've got the bottom times the derivative of the top minus the top 6x cubed plus 2x squared minus 14x times the derivative of the bottom. That's going to be 6x all over the bottom squared. 3x squared minus 6 all squared. All right, now, goodness gracious, don't try to multiply that out and simplify it. Just leave it like that. If you have to plug in a number, we'll just plug it in right there. Okay? All right, let's do one last example, and then we'll be done. Still on the quotient rule. Our example is if f of x is equal to x squared minus 3x plus 2 over 2x plus 1 what is the equation of the tangent line at the point 0, 2. Okay, this is great. We're going to plug in 0, so that's going to make it easy. First of all, let's get the derivative. Okay, we got the quotient rule. It's the bottom, 2x plus 1, times the derivative of the top. That'd be 2x minus 3. Minus, so bottom times the derivative of the top, minus the top, x squared minus 3x plus 2, times the derivative of the bottom. That's going to be 2. All over the bottom, 2x plus 1, all squared. So we need to get the slope by plugging in the x value into the derivative. Okay, so plug in 0 for 2x for x there, and that's going to be 1. And then 0 minus 3 is negative 3. 0, 0, positive 2 times 2. Then plug in a 0 there, and you have 1 squared, which is just 1. So that's going to be negative 3 minus 4 over 1. That's negative 7, and that is equal to the slope. Okay, we have y minus y1 is equal to the slope times x minus x1. So I've got y minus 2 is equal to negative 7 times x minus 0. That is fine if you're in my class. If you're required to make this into slope-intercept, it would be y is equal to negative 7x, and then add the 2 to both sides, plus 2. Okay, so the homework for product rule and quotient rule is page 121, 1 through 25 odd. Okay, so in the back of the book, they do a lot more simplification than I require. So I'm going to show you the answers in the back of the book and see how, for example, on let's say number 13, okay, I don't require you to multiply out the numerator and get that negative 5 there. You can stop at this point. Number 15, you can stop at this point. You don't have to combine like terms and multiply it all out. Same thing for 17, 21, 23, and 25. Just do it the way that, excuse me, I bumped my camera. Go do it like I did on here where we didn't keep simplifying. Now, on 25, some students get confused by this. They put in a c. Just think of the c as a 5. It's just a constant, or a 1, or whatever. So what's the derivative of a constant? All right, it's 0. Okay, so you're just going to, when you take the derivative of c squared, that's going to be 0, right? So don't let that drive you nuts on there. Okay, so 1 through 25 odd on page 121, and I'll talk to you on the solutions video.